I thought I would provide you with a little bit of homework help on a couple of problems on page 481. These were the problems that I covered at the end of the lesson in class today. You can watch the complete video lesson. It's been posted, but I thought I would go ahead, since I didn't have a lot of time to develop some of these, a couple of these problems. I'll just help you out with them right here. So let's just, let me close this. Let's take a look at number 26. All right. This is an example of combined variation. And what we mean by that is, instead of having two variables that either work together, both of them going up or both going down, which would be an example of direct, or one going up and the other one going down, which would be inverse. In some cases, we have both of these, direct and inverse, within the same function. So it's one variable, in this case z, that's varying directly with one variable but inversely with another variable. All right, so I want to show you first of all how you can come up with the function, and that'll be our answer part A, and then we'll do answer part B, evaluating the function for x is 4 and y equals 9. All right, so let's interpret this sentence. When you see a sentence like this, z varies directly with the square of x. All right, z varies directly. Remember, direct variation implies multiplication. All right, and we're multiplying our constant of variation k times the square of x, which is another way of saying x squared. All right, now it's also, not only is it varying directly, but it's also varying inversely with y. And inverse variation implies division, because remember, the inverse variation function is, well, we were looking at y equals k over x before. But remember, inverse variation has division, and direct variation multiplication. All right, so we've set it up, and now we're going to find k using these three numbers. Do you notice that they give you every number, every value, variable value in this function except for k? Well, they're doing that because instead of just telling you what k is, they want you to find it. All right, so let's substitute these three numbers in their place, and obviously we don't know what k is, so be careful here, because we're putting 2 in for x, but 2 is supposed to be squared, and we're putting 4 in for y. Okay, when we simplify this, we get 4k over 4. All right, and so obviously you can see where k would be 3. So my answer part A, write the function that models the relationship. It's going to be z equals 3. We found out what k is. 3x squared over y. Okay? Easy enough. Now let's work on part B. Part B means let's use this function that we just created, and let's put in some numbers for x and y and see what comes out for z. Okay, so they tell us to let x be 4, and we're going to let y be 9. Okay, so be careful here. Remember, order of operations. You need to do the power first before you multiply. All right, so 4 squared is 16, and 16 times 3 is 48 ninths. All right, and it's okay to leave this as improper, but we need to do reduced improper. 3 goes into both of these numbers. 3 divides into 48 16 times. 3 into 9, of course, is 3. So that's our answer part B. All right, so make sure you show these as two different answers. We found the function. There it is. Z equals 3x squared over y. and then we evaluated the function for values of 4 for x and 9 for y. Okay, that finishes off number 26, and I thought I'd help you out with number 27. Okay, this one's a little different because here we have z again, varying. So z varies inversely with the product of x and y. Well, all we have is inverse variation, but we have it with two different variables being multiplied together. So inverse variation, again, is just think division, and k being divided by the product of x and y. Okay, now let's find out what k is using these numbers. So just plug in. Z is 0.5, x is 2, y is 4. Okay, so we end up with 0.5 equals k over 8. And if I want to find out what k is, I just multiply by 8 on both sides. 8 times a half is 4. Okay, now I can write my official function that represents this relationship. Z is equal to 4 over x times y. All right, easy enough. And that's my answer, part A. Now, answer part B is, let's find out, going back to here, now find z using those same numbers for x and y, 4 and 9. Okay, so z is equal to 4 over 4 for x, 9 for y. Z is going to be 4 over 36, which reduces to 1/9. So that's my part B answer. Here's the function, finding the value for k, and then here's using the function using those given values for x and y. So I hope that helps you out, and let me know if you have any questions.